So why agroforestry? Most of you should have had lectures on agroforestry already, so you should know something about it already. Basically, it's about optimizing the positive interactions between the components, means between the trees and the agricultural crops, to achieve a more productive and more sustainable and diversified production. About more productive, I will tell you soon. Sustainable means that the trees on agricultural land can reduce, of course, erosion problems, and therefore making agriculture more sustainable. And also it's a matter of diversification in case of ecology and economics, because in case you have a drought and all the agricultural crops die, then at least we'll have the trees which have a better access to groundwater. So this is especially when you think about climate change, a possibility to reduce the risk. So this is the source of this information. And here you see another basic graph which shows about productivity, as I mentioned. If you have trees like walnuts, or if you have a crop like wheat, you can have 100% of the land with one or the other. But if you mix it, you have more than 100% of production, because of course wheat is not using the product, the soil and everything during all the year, but the trees are even green when the wheat has been harvested. So the sunlight and the water is being used more intensively if you have such kind of a mixture between trees and agricultural crops. So this land equivalent ratio is an important aspect in terms of productivity and intensive use of land. So I found an interesting book from 1929, Tree Crops, A Permanent Agriculture, from J.R. Smith in the US, who wrote this sentence here on the right side. That means here this is focusing on areas where normally agriculture is not really possible, on slopes and steep places and so on, or dry places where only trees can produce something. Basically, this picture I took last year in Portugal, where they have traditional systems of cork oak. They are producing cork, and it may be possible even to produce pigs below the cork oaks. This is a very traditional system. Or in other Mediterranean areas, for example, what is this in English? Castanea sativa. This is a castagna. No, I don't know this in English. It's a fruit from a tree which the trees are producing. Or olive is also another fruit from trees with a lot of oil in. So these systems with these fruit-bearing trees, together with pigs, for example, or goats or whatever, grazing under these trees, are systems in the Mediterranean area which have been used for centuries in a sustainable manner. And this Mr. Smith, when thinking about this, he was explaining that basically mankind is on a wrong track by producing its food mainly by herbaceous species like corn or millet or whatever kind of grasses, because by nature most of our agricultural land would be forested, of course. So trees are the more stable and more productive way of land use than agricultural plants. So it would be a better idea to base the human nutrition on trees, because they are more stable and ecologically sound. So as an example, he is calling this Castanea sativa tree as corn on trees. So I found this idea very interesting, and it's another good argument to promote more trees in landscape, because there are so many tree species which produce something edible. I mean, in your tropical area and subtropical areas, there are even more than we have in Germany. We do not have really that many trees locally which are producing food, but we could introduce more from America or from China, also from the same type of climate. And nuts, for example, are a very healthy food and growing on trees or bushes. And we should switch a little bit from grain to this kind of food, I think. And we can use more trees and have a more stable and even more healthy production of food. So this, you should keep in mind. You can find this book online, which is mentioned down there, and can download it. It's a comprehensive book showing all the different types of fruit bearing trees in America, which includes some subtropical and tropical areas, of course, like Hawaii and the southern states of the US. So it's really interesting to see how many trees there are to feed mankind. So now coming to the CO2 mitigation effects, basically there are three of them. The first, of course, is conservation of existing carbon pools, means soil and plants are the carbon pools. Secondly, also conservation is the first thing, because many of these carbon pools are still decreasing. The right picture I took somewhere south of Pune in Maharashtra, also on the way to Bangalore on the train. You see in India you can find many landscapes which are nearly having any trees anymore, even though by nature it might have been a forest or a dry forest at least. So these are depleting carbon stores, and even erosion may take place and further decrease the carbon storage in soil. So you can increase the existing carbon pools, and you can reduce greenhouse gas emissions from fossil sources in addition. Now I will explain these 3 points in more detail. So in India, I found this information recently that there are more than 107 million hectares of land unproductive, more or less. You can see on the pictures linked on the left side, both is more or less in the Himalaya region. So they have been rendered unproductive due to degradation processes. I could see something like this, and I took the pictures there in Himalaya region, but it's in other parts of the country as well. So this degradation has to be stopped to avoid further CO2 emissions from soil carbon and from trees which are being removed. And this can be done by the introduction of agroforestry systems, of course. So when it comes to carbon pools, as I mentioned, it's soil and it's trees, but it's also wood products. So wooden products are storing carbon after the trees have been felled. Basically, on the land, the biomass is a carbon store, the dead wood in natural forests, litter, soil organic common, and wood products. So this is the list from the IPCC, which is explaining this in more detail. So these carbon pools could be built up by planting trees and using timber for long-lasting products. So, and finally, the production of timber also can be used to reduce greenhouse gas emissions from fossil sources. Easy to understand if you substitute coal or oil or gas by using wood energy, as long as it is coming from a sustainable production, of course. I mean, if you destroy the forest by using fuel wood, then it's not a reduction of greenhouse gas emissions, but if you produce this material in a sustainable way, than it is. And here on this picture, you can see a picture. You can see a wood gasification plant in Odisha, which I once visited, where they make wood gas from small trees, which they regrow for this purpose, and which is being used for rural electrification. And by this, of course, being a subsidy for oil lamps or whatever you use for lighting of villages. And another important effect is if you use construction timber instead of steel. This is called material substitution. Then you can avoid all these emissions linked to steel production, starting with getting the raw material out of the ground and the processing of steel and so on. This is a very intense, energy-intensive process. And all this can be avoided if you use timber constructions. And finally, a small point is the reduction of fertilizer, because the nitrogen fertilizer production, of course, is quite energy intensive. And if you can reduce this by using compost and having a better soil life, then you really can reduce the fertilizer application and the fertilizer losses, of course, which is a problem in Germany because it's going to the groundwater, as I mentioned earlier. So it's a very unproductive loss of expensive and energy intensive artificial fertilizer, which could be reduced if we would have more soil organic matter in the ground. And even pesticides can be reduced. I will show you a picture later by agroforestry systems. Yeah, so this is the other way of gaining some progress and create advantages for climate change mitigation. So I did a study on these things in 1990 till 1993. So it's already a long time ago, more than 25 years ago. I was already working on that topic. At this time, even German politicians became aware of the problem of climate change, and there was a big commission on the German parliament to deal with this, and we had a research project about the effect of German forests and German forestry on climate change and what could be improved. And as a byproduct, so to say, we also looked at tropical forests, and I stayed for 6 weeks in Costa Rica at this time in 1991. I was staying in Costa Rica, and there I collected data and evaluated literature on this different kind of agroforestry systems they were having in Costa Rica at this time. And then I made this estimation on the potential effects of agroforestry systems on the carbon household. So these effects I just explained to you means carbon storage in agroforestry systems. There's a big variation. It depends on how many trees per hectare you are having finally. There are very different kinds of agroforestry systems, of course. Accordingly, this carbon storage is very different. Wood products, as I mentioned, wood products are the prolongation of carbon storage in trees, in living trees. It, of course, also depends very much which kind of timber you are producing in the agroforestry systems. In short rotations, you never can produce sawn timber. I mean, timber, wood for wood logs, which can be sawn and therefore for being used for construction. Of course, sometimes you can use very small diameter trees for construction, then it's not necessary to have a long rotation period, but it all depends. Then also soil organic matter can change, can be different in different systems. And another effect of the creation of agroforestry systems can be the protection of existing forests in tropical countries, especially not here in Germany, but in countries where still primary forests are being cut to get new agricultural land because the existing agricultural land is being affected by erosion, like in Brazil or in other countries, then if you can make the agricultural production more stable by creating agroforestry systems, then you can use the same land forever for agriculture and do not have any losses due to erosion, and therefore maybe not a need to go somewhere else except your population is increasing or something like this. But if it's just because of the destruction of agricultural land that you cut new forest land, then this can be prevented by the introduction of these more sustainable agroforestry systems. And therefore there's a frame of 0 to 1,000, means 1,000 tons of carbon per hectare is in a very rich tropical forest. And if this effect is not there at all, then of course it's 0. So these are the changes in storage. I have looked for some examples from India, which are in the same range, of course, of these numbers I found at this time. And the second type of effect is this energy and material substitution, which I just explained to you. So energy substitution is if you produce fuel wood in your agroforestry system and therefore don't need any fossil fuels anymore there, then this is an effect. I mean, if you can't substitute anything because they are relying on fuel wood anyway, then this cannot be taken into account. But if really you can avoid the use of fuel from other sources, then it can be counted. And also the material substitution. I mean, if you only have wood as a raw material anyway, then you cannot take this into account. I mean, for construction, you can use also building blocks, of which the production needs energy. If you make it from timber instead of this, then you avoid this energy. But this is an energy consumption, basically. Yeah. So, and reduction of fertilizer is a very small effect, but it can be taken into consideration. By the way, this publication, I can send you a copy by email if you are interested. I have it as a PDF here. So you can ask me for this publication, which is still somehow correct after this long time. And there are more studies in the meantime which find similar data. So this is now a kind of summary of all the effects I just have mentioned. I developed a similar curve at this time, but this was developed independently from my research by the IPCC. And it's maybe not so easy to understand, but I try to explain to you. So if you have a barren land or an purely agricultural used land, and you plant trees there, it must not be a forest, it can be an agroforestry system as well. Of course, one effect will be that the soil organic carbon will increase over time. So this is carbon which is being taken out of the atmosphere and stored in the soil. That is this yellow area, which will not go forever, not increase forever, but for a long time it will. Then you have litter, of course, which is falling down from the trees and laying beneath them. This will also accumulate a little bit over time. And then the next pool is trees. In this case, it's assumed that these trees are growing 40 years and then be clear-cutted. This must not be the normal way. I mean, you can do thinnings in between and get some wood earlier, not only after 40 years, but to simplify the thing, it's good to see like this. So this would be either a forest or agroforestry systems you can also change, of course, the period of time. You can do it for 20 years and cut it then, or something like this. This is just to understand the system of thinking and counting. So if you cut these trees, you have long-lived products, as I mentioned earlier, like buildings and furniture, and you have short-lived products. The lifespan, depending on the lifespan, it will be decomposed or burned or whatever after more or shorter or longer time. So the short life products will disappear, or the carbon will go back to the atmosphere relatively soon. And long life products, it takes longer. And landfill, whatever comes to the landfill will stay there for some time or become decomposed to methane or whatever. So then you get some fuel wood, which will be a substitute for fossil fuels. So this is an effect. If you don't burn this amount of fossil fuel, the atmosphere will be released by this amount of CO2 at every harvest once, and this will add up. So this is one harvest of trees. This emission reduction will be existing forever, and after the second harvest, the same amount will be added up. And the same is true for this. So this was energy for products, and this was displaced fossil fuel, but it doesn't matter. It's the same effect. So you need less fossil fuels, and this fossil fuel savings will add up over long periods, means forever. This is a basic difference to what in trees, what in forests happen if you would not cut the trees. So they would, this green thing would increase more and more, but finally end with a maximum production, because no forest grows to the sky. There will be a on the long term, there will be a steady state situation where the carbon store is full and nothing else will be stored anymore in these forest ecosystems. Sometimes it was found that some ecosystems are exporting carbon in form of humus, which will go by the rivers down to the ocean. So then still even primary forests may be a sink, even though the biomass in these primary forests do not grow anymore. But yeah, if you just look at the atmosphere, at the biomass stored in forests, they will not become bigger than a maximum level of biomass for a primary forest. So this would not increase, but if the forest is being used for production of timber, then you have, with every harvest, you have a new reduction effect by displacing fossil fuels. So this curve will go straight up without flattening at all. That in practice means basically a managed forest is a permanent CO2 pump, which takes CO2 out of the atmosphere and leads to stores and to CO2 emission reductions from fossil fuels. That is what this graph should express.